Hey guys, welcome to another video. Today I'm going to be teaching you how you can make a dash ability with effects. So basically, what's going to happen is this guy's going to dash forward, right? You're going to dash forward and then behind there are going to be some ghost-like apparitions there. So the first thing we want to do is go to Start GUI and create a script, a local script. And I put an animation in here because I want to make it like a dash isn't a dash without an animation. I already made this animation beforehand. You can make an animation yourself. You go to Avatar, Animation, and then you click on a rig, and then you can do all that stuff. But let's get into scripting. So we're gonna go here, local UIS, is equal to game, get service, user input service, and local player is equal to game, get service, players dot local player. Now we need the players player, the games local player, whatever. We need the local player because we're gonna do something using tags, and I want to include that right now. I want to teach you guys how you can use tags. So if you go up, you will on the very top, you'll see like the regular stuff, home model, all that stuff. You can press plus to create a new tab. Now I have one called tab tools, and I have the tag editor here. So what you need to do to get this is you right click and you press add tools, and then you search up tag editor. Now what the tag editor does is, I think it uses collection service or something like that. It's kind of like a attribute, but it's stored on the server. So I'm going to add a new tag called cooldown, and you can add this tag freely and remove it freely to whatever thing in the server, and it's all on the server. A lot of people in my last video were talking about how you shouldn't do a cooldown on the client side, and I was oblivious, but you really do need to do that. They're right, because exploiters can change anything that's on their side. So they can change local scripts, they can change the cooldown if you do a cooldown on the client side. So that's why we're going to use tags to make cooldowns on the client on the server side. So let's get back into the scripting now. So uis.input began connect function key then chat. So if the player's typing, then return, break that out of the function. We don't need anything else. Else if key code is equal to enum key code q, then we're going to fire a remote event. So let's add a remote event to replicate storage called dash. And also, by the way, I'll put this animation in the bio. Game get service replicate storage dot dash. I probably should put this up here. We don't want to get everything. Local event is equal to this. Event fire server. Yeah. Oh, also we want to do that cooldown thing. So the thing we can do with the cooldown, the good thing about tags is that they're accessible by both the server and the client. So if player.character.humanoid we can do a character too, but it doesn't really matter. Cooldown. The nice thing about tags is that it's not like too complex. It's just, does the player have this or do they not have it? And then if they don't have it, if they aren't on cooldown, then we'll run the next thing in the script. But if they do, then just break out of it. So we don't want anything to happen in return. Else, that means they probably do have it. They don't have it. So either, yeah, they just don't have it. Then we fire the server, and then we can do something else. We also need to load the animation. Local anim is equal to player.character.humanoid, and you can do load animation on the humanoid, but I think we can also do animator load animation. I think they come with that now. Script.dash, and then we do anim play. So let's test this right now, see if the animation works. It does. That's great. Okay, so now let's go on to the server side, and I'm just going to rename this to dash fire. So kind of do the same thing. We'll get the dash event. Event.onSer event connect function. The players are automatically passed. So local character card equal player.character. Local root is equal to car find first child root. And then I'm also going to get debris service. I love debris service. Debris. Okay, so there's some things we need to talk about right now. So last video I used vector force, but we're going to be using linear force right now because it's just a dash. This guy's just pushing forward. Vector force brings a lot of physics into it because it's a force. If you jump and then you do it, then you're going to fly away because there's no friction. So linear force is just easier to do. So local velocity, or I think it's called a linear velocity actually. Instance.new linear velocity, and then we just parent it to the root. Velocity dot attachment 0 is equal to root find first child, which is a attachment. Now I think there's only one attachment in there, but this is easier. It doesn't really matter which attachment it is. We want to make sure that it's relative to the attachment. So velocity dot relative to is equal to enum actuator relative to attachment 0, and then I'm gonna put a variable right here. Local, put a few actually. Local strength is equal to -50. We want to be negative because we're gonna go forward, and forward is always the -z. Local cooldown is equal to, let's make it 0.2. Let's do 5. It's fine. All right. Velocity dot max force. So we actually need to do this because even if you, so math.huge, wait, let me, it's weird. You have to do this so that you don't go really slow. Because if I don't do this, then the character will be moving, but just so slow, like it won't be a dash. So velocity, now we'll set the actual velocity equals vector dot new 0 0 strength. And I believe that's it. Well, we also have to parent. No, actually, we don't have to parent this. Not yet, at least. We do have to destroy it. So debris, add item, velocity after CD seconds. Actually, no. No. Yeah, actually, yeah. CD. It's a CD. After all. Yeah, see, that's cool. Alright, so let's do the after image effect now. So we're gonna make a function, local function, is equal to after images, or after image character. We'll do the after images first, then we'll do the cooldown. So local ghost is equal to the character's clone. Now the thing is, characters aren't by default able to be cloned, so we have to turn archivable to true. And then for part in ghost get descendants, what this does is just for every, like look, if you look in the rig, right, every child and then every child's child and every child's child, it'll check, it'll return a list of all of these. And the reason we did an underscore here is that we don't really care about the number in which the order this list is in. We just care about what the part is. So if the part is a base part, then we want it to be white, we want it to be neon, we want it to be anchored, we want it to be a bit transparent, and then fully transparent after a bit. We want it to fade away. So let's do all that right now. Part dot brick color is equal to brick color dot white. Part dot transparency. It's really fun when autocorrect doesn't work, or autofill. Part dot anchored is equal to true because you don't want it to follow it. Yeah, you don't want it to fall. Part dot can collide is equal to false. Part dot massless is equal to true. Part. What else do we need? let's add tween service now. I think that's good for now. Local tween or TS game get service, tween service, TS create part, and then tween service is like, if for those of you who don't know, it's a way. Well, tween service creates a tween, which is a way that you can numerically or really smoothly, you can turn something transparent. It'll gradually turn transparent. And that's controlled by the different parameters that you give it. So we give it the part that needs to be tweened. We give it the info, tweeninfo.new. Now there's a bunch of stuff here, but the really important thing here is just how long it takes. So 0.2 seconds or 0.25 is fine too. The property table is what you want to be changed. So transparency is equal to 1. We want this to be fully transparent. And then I think also, well, let's do size is equal to part.size times 0.9. I think that would be cool. Like it would shrink slightly, or I think that would be cooler. And then, so else if we don't want any, like, we want the parts, like the accessories, to stay, because that makes the person an actual person, right? So else if part is accessory, or part is because we want also the meshes to be the same, otherwise the accessory will not really load. And then the same thing for the head, special mesh, then nothing happens. Else destroy it. We don't need anything like the joints or the scripts or anything like that. Humanoid, we also don't want the humanoid. And yeah, and then at the very end, go debris, add item, ghost after 1 second. We want to make sure everything's done before we delete it. Now we also need to parent it, so let's parent ghost parent. Okay, equals workspace. If you were actually coding this for a game, you should probably put it in a folder called FX. And then let's add it here, and we also need to add the cooldowns. So task.spawn. What this does is it just creates like a new thread kind of code that'll run simultaneously. It won't stop anything here. So like before or after, it'll just like go. Oh, see this, make a parallel thread, and then that'll go, and then this will keep on going here. So we're going to do a for loop for I equals 0. 4 times, let's do 3, whatever. Do afterimages character task.wait 0.2 seconds. Yeah, so there's like a very little overlap time before the next one comes. And then let's add the cooldown. So character, a humanoid, add tag, cooldown, and then wait a few seconds, task.wait, cooldown, character, a humanoid, remove tag, cooldown. Let's move this up a bit. Then hopefully it all works. So there are a few things that I want to change. First, I wanted to make the material, the parts, neon so that they would shine brighter. Second, I didn't really like the size part, so I just deleted that. Then finally, I changed some of the cooldown times, or like the tween times, because it just felt too quick, not clean enough. And then right now you can see I'm testing out the effect, and it looks pretty cool. So I'll see you guys later. Thank you guys for watching the video.